Okay, let's see if I can record this very quickly. How to go from standard to, from general to standard. If you recall the circle, very easy to graph if I have it written in standard form, very difficult if I have it in general form. But it's very easy to go from general to standard using the completing the square. If you recall, you mastered that one. By the way, these guys are called conics. Now I just digress here. Why they are called conics? Literally because it's a cone. Okay. If we have a cone, depending how we slice the cone, we can create a circle, the parabola, ellipse, or hyperbola. That's all. Okay. These are called conics. And of course, in college algebra, we talk about circles and parabolas. Pre-calc, if and when you take those, you will be exposed to the ellipse and the hyperbolas. No big deal. By the way, we know this is a circle because this guy is positive and this guy is positive. If I divide by a number in X or in Y, and this guy and both are positive, that will be the ellipse. If one of them is a square and the other one is not, that will be a parabola. If both are square, but one of them is negative, that will be the hyperbola. Anyway, no big deal. Of course, you know this one. Let me just do a quick review. How do I go from general to standard? We call our best friends completing the square. We need to rearrange a bunch of these things. So that will be x squared minus 6x plus y squared minus 8y, and we subtract the 9. Now we add what I tell my students, the magic number. We add half of b squared, half of negative 6, negative 3. The square is 9. If I add 9 to the left, I better add 9 to the right. And we repeat the process with the 8. Half of 8 is negative 4. Square will be plus 16 plus 16. This is a perfect square trinomial. So these probably factors are x minus 3 squared plus y minus 4 squared equals minus 9 is 0 equals 16. So we know, of course, that my center here is 3, 4, radius 4. Okay. We are able to go from general to standard using completing the square. Since I'm in an equation world, if I add the number to the left, I add the number to the right to maintain the balance. We don't have that luxury in the function world. We don't have such thing as the left-hand side or the right-hand side. What do I mean? Just like in the circle, if I have the quadratic function like this, by the way, this is ax squared plus bx plus c. Notice that a is 1. So I know that this is a parabola opening up. And c is 13. I'm going to hit the y-axis at 13. So this is my y-intercept, 0, 13. Just by looking at the function in general form, I know two things. Well, open up or down. Therefore, if it opens up, it has a minimum. And I know my y-intercept. In this case, 0, 13. And we need to rewrite this guy as f of x equals a parenthesis x minus h squared plus k. So we can identify my vertex h comma k. Okay, so we are going to use completing the square. A must be 1, that's for sure. So I have x squared minus 6x. In the equation form, I was able to subtract 13. I don't have left hand or right hand, so we just push it to the side a little bit. And now we find the magic number. How much I need to add? As long as a equals 1, we look for b, negative 6. Half of b, negative 3 squared, 9. So we proceed to add 9 here. If I want to maintain the same balance, if I add 9, I better take away 9. 9 minus 9, 0. So I have not changed my function. But this is the advantage. This guy is a perfect trinomial. That will be x minus 3 squared. 13 minus 9, of course, that is 4. And we are done. Why? Because we know that this is going to be a parabola shifted 3 units to the right. So of course my axis of symmetry is x equals 3, and the vertex is somewhere. This is not at scale, obviously. From here to here is 3, from here to here is 4. So this is not a scale. Let me do a scale. So I have x equals 3 and 4 right here. So 3, 4, my vertex, and this thing is opening up because A is positive, and we knew that the y-intercept was 13. So let me just put it right here at 13. So this guy will be opening like that, and we are done. So what do we know? That this parabola experiences a minimum at this point at the vertex. What is the lowest value? What is the minimum? 4. When does that happen? When x equals 3. You could use also the vertex formula, plug in negative b over 2a, and you find the same answer. So negative b over 2a, you can do that. I'll leave it up to you to use the vertex formula so you can verify that it's 3, 4. That's it. By the way, if they ask us, we already have the axis of symmetry. I have my y-intercept, which is of course c. And if it's a max or minimum based on the sign of A, I don't have to worry about looking for the x-intercept. The vertex is already up here in quadrant 1, and it opens upwards. I will never hit the x-axis. Even if you attempt to find the intercepts, you cannot do it. You need to ask your friend the complex numbers. How do I find the x-intercepts? Y equals 0 or f of x equals 0. You don't need this, of course. We already know that they don't exist. To find the x-intercept, f of x equals 0. So how much is my f of x? Equals parenthesis x minus 3 squared plus 4 equals 0. I can subtract 4. Negative 4, we take the square root. Be x minus 3 equal plus or minus 2i. Okay, so I cannot graph it because it's a complex, and we're in the real world. And if we were to add 3, so x will be 3 plus or minus whatever. So this is your axis of symmetry. Okay, let's do another example. Second example, what about if I have the following function? F of x equals 2x squared plus 4x minus 6. Okay, so we need to go from standard to, from general to vertex form. Okay, so completing the square is our best friend. However, I cannot complete the square because a is not 1. A is 2, which is positive, so this function will experience a minimum at the vertex, and it has a y-intercept of negative 6. Okay, no big deal. So we're still going to complete the square. In the circle or in the completing the square, we used to divide by a. Here I don't have any questions, so what do? We factor out the 2 from the first 2 terms. Yeah, I'm just forced it to be a nice numbers. So I have x squared plus 2x. Don't touch the 6, leave it outside. Okay, so 2 times that and 2 times that is 4x. Okay, so now we can complete the square. So I have 2 parentheses minus 6, x squared plus 2x. What is my magic number? Half of b squared, half of 2 is 1, 1 squared plus 1. So I need to adjust. If I add 1, I need to have a 0 net. If I added 1, I need to subtract something here. But be careful, here we need to subtract 2. Why 2? But this one is being multiplied by 2. So what we are doing is actually adding 2. If I add 2, I take 2 away. The video that you have in your book, it's kind of weird. They add and subtract inside and they pull it out. I like to do it like this. This is how I like to teach my students. You add 1 because this is your magic number. That 1 is being multiplied by 2. So the net effect is 2 times 1 plus 2. Well, I added 2. Let me take it back. So we have 0 net. So now what do we have? No big deal. 2 parentheses, this is a perfect square, will be x plus 1, negative 6 minus 2 minus 8. And we are done. How do I grab this one? That will be here. We want this one goes to the left, so let me do the following. It goes to the left and down. So which one to the left? So this is my axis of symmetry. So x equals negative 1. We push it left and down. And the vertex is here at negative 8. However, we know that my y-intercept is at negative 6. So the y-intercept will be, give or take here at negative 6. And this thing opens also will be something give or take like that. And so notice that we have two x-intercepts. One of them will be negative, the other one will be positive. How do I find the x-intercept? F of x equals 0. So you have two choices. You can either do it, this guy equals 0. I won't recommend that. Take advantage that you already have it like this. So what happens when my f of x equals 0? How do I solve this guy? 2 parentheses x plus 1 squared minus 8 equals 0. I can add 8. I'm going to, because of the space, I'm going to be a little bit lazy. It's going to be equals to 8. We added 8. I need to get rid of the 2, so I divide by 2. 2 divided by 2 is 1. 8 divided by 2 will be 4. And I'm going to be lazy just because of the space. So we end up with this. How do I get rid of the square? We simply a square root plus or minus a square root to be blue. So what do I have? X plus 1 equals plus of minus over 4, which is 2. Therefore, x equals negative 1 plus of minus 2. This is your axis of symmetry. X equals negative 1. From negative 1, what do? I go 2 to the left and 2 to the right. It's symmetric. So it has to be the same distance. So negative 1 minus 2, negative 3, negative 1 plus 2, 1. Okay, so that's it. So this delta will be 2. 2 here, right? Plus or minus 2. And that's it. So this parabola, this function experiences a minimum when x equals negative 1. The actual minimum is negative 8. That's the lowest value the function assumes. Therefore, the range is from negative 8 to infinity. The domain is always of real numbers. Okay, hopefully that helps. Let me do one more example. Okay, let's try this other one. Very quickly, general form. A, the leading coefficient is negative 4. So this parabola will be opening downward. So it will experience a maximum. My C is negative 12. This is my y-intercept. Okay, so let's go ahead and write it in vertex form. So the first thing we do is factor out the A in the first two terms. So it will be x squared minus 4x. This time that positive. Minus 12. Now we find the magic number. Half of negative 4 is negative 2. Negative 2 squared will be 4. So we proceed to add 4. I add 4 in I add 4 here. Yeah, okay. But now this 4 is being multiplied by -4. So what do? We are taking away 16 already. Minus 16, so I better put it back. Plus 16. -4 times 4 is -16. So let's go ahead and place it back. So we have the 0 net change. So that we have for -4 squared, that would be x minus 2. This minus that would be plus 4. Ooh, sorry. Okay, that's it. So this parabola is 2 to the -4, so it goes to the right and up. Let's see here, up and this, so x equals 2. Vertex, my axis of symmetry, 4. And this is 2,4 my vertex, so that's the highest value, 4. And the y-intercept is -12, so somewhere down there. Okay, so my parabola would be like that. Looks like looks more at the doesn't look like a parabola at all. Looks like absolute value, but you get the idea. So it has 2 x-intercepts, and both x-intercepts are positive. So I'll go find the the x-intercept, f of x. This one is quick equals 0. So -4 parentheses x minus 2 squared plus 4 equals 0. We subtract 4, so it will be equals -4. We divide by -4, so it will be equals 2. Sorry, I'm going very fast here. Square root x minus 2 equal plus 1. So x equals 2 plus or minus 1. Yeah, exactly. My axisymmetry is x equals 2. And from x equals 2, I go 1 to the left and 1 to the right. So 1 and 3 are my 2 x-intercepts. I ran out of space there, but you get the idea. And then the last one, this one is very quick. Minus x squared minus 12x. Of course, my y-intercept is, my c is plus 0 here. This is c0, so that's my y-intercept. 0, negative opens up. So it has a maximum. So it's straightforward. So what do? We factor out the negatives. I'm going to write -1, even though it looks ugly, but I know that I'm always factoring out the a if a is not 1. I'm going to factor -1. That will be x squared plus 12x. Okay, so half of 12, 6. The square would be 36. So I need to add 36. So I have a perfect square, perfect trinomial square. But the 36 is being multiplied by -1. So we're actually taking away 36. So I better put it back. So we have opposite of x plus 6 squared plus 36. We're done. Big numbers. Goes to the, this one goes left and flips the reflected and up 36. Oof. And the y-intercept is, of course, 0. On this one, I don't even have to look for the x-intercept, so we'll see if we know it. Why not? I'm going to write this very small here, 36. This is in my way. What am I doing? Okay, so big one. So we push it 6 to the left. X equals -6. Just right top. The vertex, 36, and then 6 of here. This guy is 36. And we are going to hit the y-axis, the origin at 0. Okay, so this is my parabola. Okay. Of course, I have 2 x-intercepts. One is here, the other one is here. This one I don't have to look for it. Remember that the axis of symmetry is x equals -6. This guy, of course, is 0. So obviously from here to here is 6 units. So it's symmetric. So I need to go 6 units to the left. So this guy better be -12. Which, of course, we know in this case is better just to use this guy. When I have minus x squared minus 12x equals 0, I can factor negative x. That will be x plus 12 equals 0, minus x equals 0, minus x equals 0, so x equals, of course, x equals 0, and then here x plus 12 equals 0, x equals -12. And that was easy just to use the original. Of course, if we got used to the standard here, so what do we have? Negative x plus 6 squared plus 36 equals 0. We subtract 36, so we get minus 36. We divide by -1, so this will be positive. We take the square root, x plus 6 equals plus or minus 6, x equals -6 plus or minus 6. Axis of symmetry, x equals -6, 6 to the left, or 6 to the left, and 6 to the right. -12 and 0. Fini. Hopefully that helped. So I recorded 2 videos. The first one, obviously, I addressed the question that you asked me, and then I just got crazy. Just happened that this is what I was teaching this morning with my face-to-face classes. Okay. Best of luck. Thank you.